Hello, I'm Waals. Welcome to my channel, Learning Builds Life, and today we are going to talk about weak chemical interactions. Till now, we have learned about covalent bonds and ionic bonds. Covalent bonds and ionic bonds. Then what are these weak chemical interactions? These are some of the interactions which are much important, like they're as equal as important as covalent bonds and ionic bonds in the integrity of molecules and compounds. Weak chemical interactions are as important as are covalent and ionic bonds. Ionic bonds in the integrity of molecules and compounds. Molecules and compounds. We will talk about two very crucial weak chemical interactions which are needed for integrity of these molecules and compounds, which are hydrogen bonds and van der Waals interactions. Hydrogen bonds and van der Waals interaction. First, we will talk about hydrogen bonds. Hydrogen bonds the name itself suggests that this has something to do with hydrogen. Okay, let's say in hydrogen atom, the hydrogen atom, H, the hydrogen atom, if it's covalently bonded to any electronegative atom, then it forms a partial positive charge, which we have discussed previously, is represented with delta plus. Now this partial positive charge can non-covalently bond with any electronegative atom which has a partial negative charge, non-covalently bond with like delta minus. A partial negative charge is represented with delta minus. This non-covalent bond, which is formed between the partial positive charge of hydrogen, which is bonded to any electronegative atom, and an electronegative atom which has the partial negative charge, is called a hydrogen bond. These hydrogen bonds also are a constituent in DNA. DNA, which is deoxyribonucleic acid. Deoxyribonucleic acid. One example of hydrogen bond is H2O bonded to NH3, ammonia. H2O, that is water, and ammonia. NH3. I'm just drawing that. This is H2O. Now this, which has the partial positive charge, this also has, it can also have a hydrogen bond with anything else, but I'm showing with this. This dotted line, which is not the proper line, is a covalent bond. This dotted line represents that it is a hydrogen bond with the ammonia. Excuse me. Actually, this is not where it ends. Hydrogen bonds can move on to vast extents. Like I just said, this one can hydrogen bond with anything. These hydrogen atoms can hydrogen bond. Then whatever those will bond with, those can also bond. It can form like vast compounds. Hydrogen bonds are having variety. Like I said, here it can, here it can, here it can, like branches. So this is all about hydrogen bonds. Now you may take a look at the board. Moving on to van der Waals interactions. Let's move on with van der Waals interactions. Interactions. What are van der Waals interactions about? It's much similar to the hydrogen bonds. Over here, it's actually created when there are regions, suddenly regions of positive charge, regions of positive charge and negative charge are created. Then those regions of positive and negative charge, they non-covalently attract and form these van der Waals interactions. The regions non-covalently attract and form these interactions. The regions non-covalently attract and form these interactions. One very common example is the gecko's foot. The gecko is a type of a lizard which can stick to walls and walk, even the house lizards. But what is that makes these lizards walk on the wall, especially the gecko we're talking about? The main reason is these van der Waals interactions. Regions of positive and negative charge are created, which leads to an attraction. But over here, how is the foot holding the whole body weight? Well, it's actually by increased surface area because of increased surface area created by the hair on the gecko's foot. Because increased surface area created by the hair on the gecko's foot. Because of this increased surface area, the van der Waals interactions are numerous. Excuse me. Are numerous which is allowing the gecko's feet to hold the whole body weight off that gecko, because of which it can walk on the walls and it can do all that stuff without falling off. So that's the reason why the gecko can walk, because of van der Waals interactions. From here we can understand that van der Waals interactions and hydrogen bonds, and also ionic bonds when dissociated in water, these are some of the very important weak chemical interactions which make up for the integrity in the structure of molecules and compounds. To conclude, once again I say weak chemical interactions are one of the constituent parts the integrity and bonding in molecules and compounds. Now we may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.